Okay, so today we are going to be talking about factoring. This is literally one of the most important things that you're going to be doing all year. So we're going to be spending a lot of time on this. You're going to be spending literally as much time doing this as you will any other single skill that you'll be doing in here. Okay? And before I keep going, I just want to let you know that if you hear people mocking me, it's either Mr. Molesky, Miss Hannick, or Miss Ozzy. Go ahead and say hi to the kids, guys. Okay, so now that we're back and we're focused, we're factoring. So factoring is solving quadratic equations. Not necessarily, we haven't gotten to solving yet, so we're just going to be simplifying these quadratic equations. Um, but this is a method that we'll use to solve these. So you'll need to keep that in mind when we do go solve these. Go to solve these. Uh, and we want to write a quadratic equation or quadratic expression as a product of two linear expressions. So two linear things. So x plus whatever, or some number times x plus whatever. Okay. But before we do that, let's go back to something you know so you don't freak out on me. All right, we're gonna try factoring numbers. You did this in grade school, so don't pretend like you didn't do this if you want. I know you did. Okay, so we want to factor 6. We want to factor it into its prime factorization. So 2 times 3 is going to give us 6. Both 2 and 3 are prime, which is what we want. 35 factors to 5 and 7. 5 and 7 are both prime. Um, Now you want to ask yourself, how can we check that we factored those things correctly? How can we check that we factored those correctly? The way that we check them to find if we factored them correctly is just to multiply it back together. So 2 times 3 is 6. 5 times 7 is 35. Okay? So multiplying them back out will help you to check whether or not they are correct. All right. Is it always easy to factor a number into prime numbers? So 253, can you factor that into some primes? Well, 253, let's see. Does it divide nicely by 2? No. 2 doesn't divide nicely into it. 3, does 3 divide nicely into it? Let's see. 7 plus 3 is 10. Nope, 3 doesn't work. 4, nope, 4 doesn't work. 5, nope. 6, nope. Okay. But 11 divides nicely into 253. So if we check that, 11 and 23 are prime factors of 253. So we want to find prime factors. 161. What divides nicely into 161? 7. 7 divides nicely into 161. So we have 7. 7 into 161. 7 goes to 16 twice. 7 times 2 is 14. 2, 1, 23. So there's another 23. Okay. So sometimes you might have to guess and check, just like I did. I wrote all those things that could be there until we got to 11, until we got to 7. You might have to do some trial and error. You might have to do some trial and error when it comes to factoring, although I think you guys will be okay. You'll get this a little faster than you might think you will. Okay, now here's some examples of stuff that has already been factored. We've taken those quadratic equations and we've factored them into linear expressions. Okay, we're not going to worry about how to find them yet. I'm just telling you that this is true. Believe me. I promise you I'm not lying to you this time. Okay, so x squared plus 7x plus 10 factors nicely into x plus 2 times x plus 5. Okay, x squared minus x minus 6 factors nicely into x minus 3 times x plus 2. And x squared minus 9 factors nicely into x minus 3 x plus times x plus 3. So how do we check if the factorizations are correct? If we back up, how do you check to make sure that these are factored correct? You multiply them together. So if we're factoring more things, how do you make sure that these are correct? Multiply them together. So how do we multiply them together? Okay. This is a thing that hopefully you'll remember how to do. If not, we're going to go over it real quick. Okay. So the key to doing this, to factoring something, is remembering how to check it. All right. Multiply the factors together by foiling. You're going to need to check yourself a lot while you're doing this. So x plus 2 times x plus 4. If you FOIL, remember, first, so x and x, first, outer, 2 and 4, inner, so 2 and x, and last. x and 4. So we have x squared, x times x gives us x squared, x times, or let's see, first outer, so x times 4. What am I doing? Yes, there's a 4 involved. Good job, Mr. CJ. X times 4 is that one. Inner, first outer inner is the 2 times x, and then the last. Sorry, I kind of switched my green and my black. Let's do that. Last and inner. Okay, first outer inner last. Those are the 4 multiplications that we needed to do. Now, when you add them, when you simplify them, you're going to get this 4x and 2x are going to add together to get 6x. So you want to make sure 4 and 2 are going to multiply to be 8. 2 and 4 are going to add to get 6. Right? So we're going to try a couple from scratch. Try to remember this example. Okay? What is going to, when we multiply it together, what's going to give us our equation that we're starting from? Okay? Let's pull up a window shade so that we can't see some stuff. I don't know where it is. There it is. Found it. Fixed it. Okay. So that's the example we checked. So 2 and 4 multiply to get to be 8. They add to be 6. So they multiply to be the last one, the last number. Multiply to be the last number, and they add to be the middle number. Multiply to the last, add to the middle. So we want to find the factors of the expression x squared plus 8x plus 15. So we want to multiply to the 15, and we want to add to 8. Can you think of two numbers that when you multiply them together, you get 15, but when you add them together, you get 8? Okay? Keep that in mind as we keep going. So we know that we're going to have something times something that's going to give us this expression. Okay? So write the parentheses out. Just write them down. We don't know necessarily what's going to go in them, but we know something is. Then the first blanks in each parentheses must multiply to x squared. So what times what is going to give you x squared? Or I guess what times itself is going to give you x squared? That's when you get x and x. Okay? X and x. So the second blanks in the parentheses must multiply to 15. All right, have to multiply to positive 15. So two numbers that multiply to be positive 15. This is where it can help to make a table. So we'll start with 1. 1 times what's going to be 15? 15. Does 2 multiply by anything to get to 15? We're generally going to try to stay with whole numbers. I mean, there will, or yeah, generally try to stay with integers with these. Every once in a while, you get, a root teacher or whatever who will be like, haha, I'm going to give them a decimal. And that's just kind of not nice. So 1 and 15, 3 and 5, 5 and 3, 15 and 1. Okay? Again, order doesn't necessarily matter in this particular case, but it will in down the road. So we need two numbers that multiply to 15 but add to 8. Either of these pairs will do. So positive 3 and positive 5 add to 8. Now we need to check it. Check it out. X times x times x will give us x squared. 3 times x will give us 3x. X times 5 is going to give us 5. And 3 times 5 is going to give us 15. Not quite sure why I circled 3 of them and drew an arrow to one of them, but hey, it works. All right, it's fine. The arrow is cool. He's awesome. He's just hanging out pointing at stuff. Okay. So they multiply to 15. 3 times 5 does add to 15, and then 3x plus 5x. These two added together is going to get us back to 8x. Okay, cool. All right, so there's our example again that we checked. Multiply to be 8, add to be 6. So find the linear factors of this expression. All right. Give it a try. All right, remember, you need to, here, I'll leave the, okay, so there's the strategy. Following those steps, see if you can come up with your answer. Take a couple seconds, knock it out. Okay. All right. Here's hopefully what you did. All right. Parentheses for the factors. Nailed it. Okay. First blanks must multiply to be x squared. What are they? Hopefully, the first blanks in each parentheses must multiply to be x squared. Hopefully you got x and x. So the second blanks in each parentheses must multiply to 15, but they have to multiply to be negative 15. Excuse me. Whoopsie doodle. They didn't have to add to 15. Negative 15 and add to negative 2. So two numbers that multiply to be negative 15 and add to negative 2, we get negative 5 and positive 3. Negative 5 times positive 3 is negative 15, and negative 5 plus 3, negative 5 plus 3 is negative 2. Okay? I apologize for that error in the directions, but you're multiplying. To get this last number, you have to multiply. Multiply the last two. Multiply the last two, or the last number. Multiply to the last number. Sorry, I knew I forgot a word there. The last number, and then you have to, for this middle number, the two guys who live here and here have to add to the middle. Okay. So multiplying to the last number, adding to the middle number. Okay. So I have every confidence that you're getting this and you're understanding it. All right. Here is a few to practice. I will talk you through these. If you want to get on like a FaceTime or whatever, you can talk to another person. But when the people I stole this from made it, they were in a classroom. So that's why it says what it says. But you're on your own. You could do this. I believe in you. Give these a shot. I'll be right back and you'll have the answer. Okay, so for this first one, if you multiply 1 and 5, you'll end up getting 5. If you add 1 or positive 1 and 5, you get 6. Okay? So again, we're thinking about these by the way that they are checked. So that's the first one. This is the second one. Apparently I decided to grab. So negative 1 times negative 5 is still going to be positive 5. Negative times a negative is going to be a positive. Negative 1 plus negative 5, whoops, come back. Negative 1 plus negative 5 is going to be negative 6. So you want to really pay attention to what is actually what you're trying to multiply to and what you're trying to add to. So negative 1 times positive 5, negative 1 times positive 5 is going to end up being negative 5. Negative 1 plus positive 5 is going to end up being 4. Negative 1 plus negative 5 is going to be negative 4, and negative 1 times, or positive 1 times negative 5 is going to also be negative 5. Okay? So there's various combinations and stuff that can give you very, very different results. Okay? There we go. One more page of practice, and then you'll have some practice stuff to do tomorrow in class. Okay, and here's the answers for these. Notice negative 1 times 11 times positive 11, negative 11. 11 plus negative 1 is 10. And then if you go through all these, you'll check and find out, see that they're all correct, okay? So multiply them out, add them together, and then you'll see that they are all indeed, they do end up being these guys over here. Pay special attention to these bottom guys right here. These are called the difference of perfect squares, okay? If you have a difference of perfect squares, the last number, so like these guys right here, are all going to be the same. They're all going to be the same. So the first parentheses and the last one are going to be the same. Oops, doodle. The difference is in the signs. So if we have different signs, 2 times, or negative 2 times 2 is negative 4. Negative 2 plus 2 is 0. Negative 3 times 3 is negative 9. 3 plus negative 3 is 0. 5 times negative 5 is negative 25. And even though you can't see the 0x right in here, If you don't see anything, then that means that there's a 0 in front of it. It's been multiplied by 0, so it's gone. So then -5 times 5 is -25. -5 plus 5 is 0. Okay? All right, so that is the first phase of factoring, if you don't mind all the sounds. So those are what you need to figure out, try, and then you'll have some stuff to do in class tomorrow or at home tomorrow if you're on retreat. So if you're on retreat, please enjoy that, and do your best to try to get yourself closer to God. And I will see you either tomorrow or on Thursday. Have a great one. Bye.